So yeah, so our objective for today, I can solve and graph two variable equations. So as you're copying down the objective, let me just recap, and I'm going to do a timeline. How about that? Damn. You guys love timelines, right? What? Didn't you guys just do one in social studies? All right. So, I mean, most of you did one, right? Okay. So we started with real numbers at the, remember the beginning of school year? Oh, remember the first week? You guys are like, what a piece of cake this class is going to be. Yay. We started with real numbers. What did we do with real numbers? We added, subtracted, multiplied, and divided. We did a bunch of stuff with them, right? We did additive inverse property. We did identity property of addition. We did commutative and associative to combine stuff. We did order of operations. Remember that with all numbers and stuff. From there, we moved on, and I introduced a variable. I showed you that video. The lesson with Andrea Bocelli and Jacob. What's his last name? Sartorius. Yeah, that he came in and no longer was it opera, it was the other. So we introduced a variable called variable expressions. So we continued on with expressions for a while. We combined like terms. We did a bunch of stuff, distributed property, commutative and associative property, and so on and so forth. And from there, we rolled it over to exponential expressions. We did rules of exponents. Remember that? Yeah, fun stuff. And then we got to your favorite, polynomials. Remember that? Yeah. Pretty good, right? And what did we do with polynomials? We added, subtracted, and multiplied. We still haven't got to division. You're like, oh, snap. I know, right? However, we did divide monomials. That's how we did the rules of exponents. Remember, when we divide, what happens to the exponents? They subtract. That's how we did division of monomials. So we still haven't gone to division of polynomials. However, from there I said, let's move on, and we got to one variable. And then we did what? Equations. And we also did what? Inequalities. Remember that? We did a bunch of stuff, multi-step, distributed property, variables on both sides, absolute value for both. Remember that? Fun stuff. Well, guess what? Now we're moving on. And what's our next one? Two variable equations. And that's where we're at so far. Okay? However, without moving forward to two variable equations today, we're going to look at something very particular that's called literal equations. They could be two variable, but they cannot. Or they might not. And I'll explain it right now with the definition. So, before we move on, though, let's see. Let's see how well we remember our definition. Writing utensils down, look up to the screen. Hold on. I want you to think back to one variable equations. And I remember I underlined something on the definition. I don't know if you guys remember. I underlined something and then something else. Remember that, to simplify the definition for one variable equations. So, if you can remember, or if you can't remember, talk it over with your neighbor without looking at your notes. Talk it over with your neighbor and see if they know the definition for one variable equation. All right. So who has a definition for one variable equation? Luca, go. Very close. You said two mathematical statements. And it's not two equations. Isaac? So it's two expressions. What else? Equal to each other, containing one variable. Okay, so that's for one variable equations. Now look at this one. This one now it's called two variable equations. Talk it over to your neighbor, let them know what the definition is for two variable equations. right, let's see. Ryan, go. 2. Wow, very good, very good. 2 expressions. Man, you're on a roll. Expressions equal. Woo! There you go. To each other. Hold on. Hands if you agree with that so far. Okay, write it down, please. 2 expressions equal to each other, comma. Pass it to someone. Julian, finish it off. With 2 variables. Hands if you agree with that. That is correct. So let's see. Let's break this down. Destiny, give me an expression. I'm not asking for an equation, an expression. Tell me what you write. And make sure it has a variable, right? Okay. 2x plus 3x. Okay. Is this an expression? Can we combine these two, by the way? It becomes 5x, right? All right, but without combining it, so far, we agree that that's an expression. Who can give me another expression now with a different variable? Marissa. 2y. 5. Do you agree this is another expression with a different variable? Yes. So far, expression and expression. What does our definition say? 2 expressions what? So what do I need else here? An equal sign with 2 different variables. Do we have 2 different variables? Yes. Do we have 3 different variables? No, because these become 1 variable, don't they? So this is a good example. Good. You can give me another example. Julian, go. 3q plus 4z plus 1 plus 1 2. Hands if you agree that that's 2 expressions equal to each other. Oh. No, but let's look at that one. Let's look at that one. Do we have 2 expressions equal to each other? Yes. Do we have 2 different variables? Yes. This is a good example. Write that down. All right. Now write your own example. Do that right now, please. Write your own example. And share that with your neighbor. If they have it right, make sure that you copy theirs and they copy yours. All right. So you got your third one. I'm going to write one myself. I'm going to write m plus j equals 23. All right. Pretty good, right? Get it? MJ? Never mind. All right. Now that we have our examples according to the definition, 2 expressions equal to each other, 2 variables. Now let's write non-examples. Who can get us started with a non-example? Somebody that hasn't been called on. Who hasn't been called on? Pablo. (3x plus 3y plus 3z equals what? 9. Hands if you agree this is a non-example. Tell your neighbor why this one is not a two-variable equation. That is correct. This has three variables. So what would this one be called, everyone? Three-variable equation. And we are going to get to those towards the end. I'm going to get you to Algebra 2. We're going to do some Algebra 2 later on. So write that down, please. So we're done with an equation. I want the next non-example to not be an equation. Help me out with that one. Pablo, pass to someone. Brody. 5/6. Hands if you agree with that. Tell your neighbor what this one is called. Aside from a fraction. An expression. That is correct. So we're done with equations. We're done with expressions. So the next non-example could not be an equation and cannot be an expression. Talk to your neighbor. Let them know what other non-example can you write in there. All right, pass someone, Brody. -3. Okay, what is this called, everyone? An expression, and I said no more expressions. Who can fix that, including that -3? Fatima. E? 8. Hands if you agree that is not a non-example. That is correct. This is a inequality, and right now we're doing what? Equations. Julian, yes.
Smiley face, 3 smiley faces equals to flowers.
3 smiley faces equal to a frown. That is incorrect because we already covered equations. All right, we're done with that. Get some hashtags in front of you. Hashtag something. You need at least 3 of them. Hurry up, please. Share with your neighbor some of them so you can write down. Julian, go. Hashtag what?
2 variables.
2 variables. Hunter, go. No expressions. One more. Reagan. No inequalities. Qualities. All right, and you get the rest, yes? All right. So for today's lesson, write down the next steps, please. It's only 2 steps, very simple. Solve each side of the equation. Start with grouping symbols and combine like terms. And step 2, isolate the variable by using inverse operations. Copy that, please. 1 minute, go. So today, like I said, we're starting with 2 variable equations, but we're looking at literal equations today. So before I move on, though, let me just elaborate on literal equations. So for example, if I gave you the formula, a formula is an equation that states a rule. And here's the formula, D equals R times T. This is what we call a literal equation because literal equations have 2 or more variables. What are literal equations? Equations that contain what? 2 or more variables. So let me elaborate on that. So let me give you this equation. D equals R times T. All right. By looking at it, which variable is by itself? D. That's why we have D as isolated. Remember that word isolated? That's why I've been using that step in our solving equations. Isolate the variable. Does that make sense? All right. So in this case, it's solved for D. It's already solved because it's D equals to whatever, or it's isolated. However, look at this. What if I did an example, Q, using this formula, and I said, solve for T. Don't say it out loud. Look up. If I needed to leave T by itself, tell your neighbor what you would do right there. And by the way, it says here by using what? Inverse operations. Itself, what will you do? Divide by r both sides. Whatever we do to one side, we do to the other. So we're left with d over r equals t. Is t isolated? Yes. Did we solve for t? Yes. Copy that. That's example Q. And this is called a what? A literal equation because it has two or more variables. You don't have to copy all the rest on top, just set example Q. Now for tonight's home play, you got to trust your steps. Remember we've been practicing all the steps that I told you not to skip? Remember that? Yes, Mr. Key, you told us all the time not to skip steps. And of course I did all the practice. All right, good. Because today you have to show the step with the variables. Do you see any numbers? No. That's why you got to trust the process that you have in your noodle. All right? So check this out. Just to clarify. Let's see. I'm going to write a two-variable equation. Look up. 2x plus y equals 6. Is this a two-variable equation? Yes. Expression equal to another with two variables. All right. And can I write this as a literal equation? 2x plus y equals 6. Do you agree with that? Do you agree with that? Okay. Tell your neighbor once again, what are literal equations? Equations that contain what? Two or more variables. So could I write this one over here? Yes, because it has two or more variables. Okay. Now let me give you another literal equation. 2x plus y equals 6z. Is this a literal equation? Could we write this over there? Tell your neighbor why not. All right, so what can we conclude? Can two variables be literal equations? Can literal equations be two variable equations? Sometimes, only when they are what? Two variables. But other than that, no, because they contain more than two. Everybody got it? All right, do these next two by yourself. Example 1A and 1B. Let's see how you do. Get it? Example 1A, 1B. Let's see. You know, like what? Example 1A says solve x plus y equals 15 for x. And this one, solve pq equals x for variable q. I'll give you 1 minute. Is that okay? Okay, I'll give you a minute and a half. Ready, go. Copy that and go. Oh, I forgot to get you guys started. There you go. Boom. There you go. All right, let's see. How about Paul? This one, what do we do? It says solve for x. Need to isolate x, so what do I do? Minus y. So we end up with x equals, look how I'm going to write this side. Look up. Tell your neighbor why I wrote it like this. That is correct. We've been practicing what? Standard form. There it comes first. Constant goes at the end. Julian, did you catch that? What did I just say? Why did I write it like this?
We could solve the X, like another variable and just try that.
Okay, so you missed the whole thing because it needs to be in what? Standard form. Variable first and then the constant. Focus, please. This one right here. Help me with this one. Destiny, what do I do? Isolate Q. So what do? Divide by P, divide by P. So I end up with what? X over P. Hands if you got that. That is correct. Crank it up a notch, yes? Yes. Copy this one. Example D. 1D. Somebody said earlier, One Direction? Oh my goodness. One Direction. Are they still like playing? Are they still a band? All right, do this one together. Let's see. Oh, let me get you started. My bad. Bam. There you go. All right. What do I do from there? Michael. Multiply times M. Multiply times M. Let's see. dm equals m squared over v. That is not true. You're saying, but doesn't the m go on the bottom? No, because it's m over 1, isn't it? So m times m is, we have a dilemma here, okay? Luca, what do? Divide by m. So if we divide by m, so it goes in the denominator, divide by m. So let's see. v over m equals 1 over v. Close, but v is still in the denominator. Mel. Multiply by its reciprocal. So what do I multiply it by? V over 1. That is correct. Multiply times v. Multiply times v. So we end up with dv equals m, because the v becomes v over v, which is 1. But are we done solving for v? What's my next step? Bless you. We need to leave v by itself, right? Divide by d, divide by d. So we end up with v equals m over d. That is correct. I just wanted to walk you through that process because some are going to take you time to develop and find the variable by itself. Let's do another one of these. Example 1, super duper Q. A equals B over C. Bless you. And I want you to solve for C. Bless you. Solve for C on that one. Let's see how you do.
Oh, I get it. Because C.
Yes. For C. All right, Brody, go. What do I do? Multiply C to both sides, so we end up with AC equals B, because this is a giant 1. And then divide by A, therefore C equals B over A. Hands if you got that. All right, your home play for tonight. Home play is on page 110. Do all, only. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye, and welcome to two variable equations. Let's go. Bye.